Morning everyone, this is Reshmi working as an assistant professor in Emmanuel Elsa JJ College of Engineering and Technology. Now we are here to know something about gully control structures. So let's move on to the definition of the gully control structures. So gully control structures are engineering and biological measures constructed to reduce the runoff velocity, check soil erosion and stabilize the gullies. These structures help in preventing further widening and deepening of gullies. The gully control structures are nothing but it is an engineering and biological measures constructed to reduce the runoff velocity, check soil erosion and stabilize the gullies. These structures help in preventing further widening and deepening of the gullies. The gully control structures are engineering structures constructed across or along gullies to reduce the speed of the flowing water, control the soil erosion and stabilize the gully. They also help to retain the sediments and improve the water infiltration. The gully control structures or engineering structures constructed across or along gullies to reduce the speed of flowing water, control the soil erosion and stabilize the gully. They also help to retain the sediments and improve water infiltration. So, the gully control structures is nothing but it is an engineering and biological measures constructed to reduce the runoff velocity, check the soil erosion and stabilize the gullies. These structures help in preventing further widening and deepening of the gullies. So this is the diagram of the gully control structures. It is constructed around the dam to prevent the flowing of water and the control the soil erosion, and it may also help to stabilize the gullies. So this is the main diagram. I think that the diagram is little most blur in this picture, so make use of a Google to search about the picture of this gully control structure. So now let's move on to the objectives of the gully control structure. To reduce the speed of the flowing water, to prevent the hardwood erosion, and to stabilize the gully bed and side slopes, to promote the deposition of silt, to reclaim the eroded land, to control the soil erosion caused by flowing runoff water, to reduce the velocity of water flowing through gullies, to prevent further deepening and widening of gullies, to trap and retain the sediments carried by the runoff, to increase the water infiltration into the soil, to conserve soil and water in the watershed, to stabilize the gully banks and beds and prevent the collapse, to protect the agricultural lands, roads and other structures from erosion damage, to promote the vegetation growth in degraded gully areas, to improve the groundwater recharge and overall watershed management. So once again I repeat it all that it is to control the soil erosion caused by flowing runoff water, to reduce the speed of the flowing water, to reduce the velocity of water flowing through the gullies. It is to prevent the headward erosion, to prevent the further deepening and widening of the gullies. It is to stabilize the gully bed and side slopes. It is to trap and retain sediments carried by the runoff. It is to promote the deposition of silt. It is to increase the water filtration into the soil. It is to reclaim the eroded soil. It is to conserve soil and water moisture in the watershed, to stabilize the gully banks and beds and prevent the collapse, to protect agricultural lands, roads and other structures from the erosion damage, to promote vegetation growth in degraded gully areas. It is to improve the groundwater recharge and overall watershed management. Now let's move on to the principles of the gully control structures. So the principles: control runoff from the catchment, treat the gully from downstreams to upstreams, combine structural and vegetative measures, ensure proper spacing and alignment. And in deep it can be written as reduce the runoff velocity. Structures should slow down the flow of water through the gully. It controls the erosion. They should prevent further erosion of the gully bed and the side slopes. It traps the sediment. Structures should allow soil particles carried by runoff to settle and accumulate. It stabilizes the gully bed and the banks should be protected from further damage. Safely dispose of excess water. Structure must provide a safe passage for overflow water without causing damage. Increase infiltration. Slowing runoff gives more time for water to infiltrate into the soil. Uses the suitable materials such as stones, vegetation, gabions, masonry or concrete should be selected according to the site condition. It may also provide a proper spacing structures that should be placed at a suitable intervals based on the gully slope depth and the runoff condition. It may ensure a strong foundation for the structures that must be properly anchored into the gully bed and the banks to prevent the failure. And it may also encourage the vegetation growth around the structures, helps to provide the long-term protection and stabilization. Once again, it may tell us it is to reduce the runoff velocity, that the structure should slow down the flow of the water through the gully. It may control the erosion. They should prevent further erosion of the gully bed and the side slopes. It may trap the sedimentary for the structures that should allow the soil particles carried by the runoff to settle and to accumulate. Stabilize the gully to the gully bed and the banks should be protected from further damage. It may safely dispose the excess water from the structure that must provide a safer passage for overflow water without causing damage. It may increase the infiltration, slowing runoff, give more time for water to infiltrate into the soil. It may use a suitable material such as stones, vegetation, gabions, masonry, or concrete that should be selected according to the site's condition. Provide a proper spacing. The structures that should be placed at a suitable intervals, which may be based on the gully slope depth and the running condition. Ensure a strong foundation, that the structures must be properly anchored into the gully bed and banks to prevent the failure. They encourage the vegetation, that the vegetative growth around these structures helps to provide the long-term protection and the stabilization. So I hope you all understand about the principles of the gully control structure. Now let's move on to the types of the gully control structure. Types of gully control structures, there are two types of gully control structure. One is temporary gully control structure and the other is permanent gully control structure. Under temporary gully control structure, there may be four types: brushwood check dam, loose rock check dam, earthen check dam, vegetative check dam. And in the permanent structures, there may be three types: drop spillway, chute spillway, and drop inlet spillway. So as in the final, there may be nearly 7 to 8 types of gully control structures. The main thing is that temporary structures and the permanent structures. So now let's brief note about the permanent structures. So permanent gully control structures are strong, durable structure constructed to control gully erosion for a long period. The permanent structures are strong, durable engineering measures constructed in large, deep, and active gullies where temporary measures are not effective, and they are generally used where the runoff is very high or where the temporary structures are not sufficient. They are designed to withstand the high velocity runoff and provide a long term stabilization. So, long term stabilization. In the permanent gully control structures, there are masonry check dam, gabion check dam, concrete check dam, drop structure, chute spillway, sill or grade control structures. Various types of permanent gully control structures are present. First is masonry check dam, constructed using stones, bricks, and a cement mortar, reduce runoff velocity and traps the sediment suitable for relatively stable gullies. Gabion check dam made of wire mesh boxes filled with stones, flexible and allows some water to pass through. Useful for controlling erosion in active gullies. Concrete check dam constructed using reinforced or plain concrete, strong and suitable for areas with a heavy runoff, provides the long-term gully stabilization. Drop structure allows water to fall safely from a higher level to a lower level. It prevents the excessive erosion caused by the high velocity flow commonly used in steep gullies. Chute spillway provides a protected pathway for carrying runoff down a steep slope. It prevents the uncontrolled water flow and the gully formation. Sill or grade control structures constructed across the gully bed. It controls the bed level and prevents the further downward erosion. So there are advantages: long lasting erosion control, stabilizes gully beds and banks, reduces runoff velocity, traps sediments, protects agricultural land and infrastructure, helps to improve the water infiltration. So once again I repeat that the permanent structures is nothing but they are strong, durable engineering measures constructed in large, deep and active gullies where temporary measures are not effective. They are designed to withstand high velocity runoff and provide a long term stabilization. It may also generally used where runoff is high or where temporary structures are not sufficient. They are generally used where runoff is high or where temporary structures are not sufficient. So the next one is drop spillway. A drop spillway is a permanent gully control structure designed to carry water safely from a higher elevation to a lower elevation while preventing excessive erosion of the gully bed. A crop spillway is a permanent gully control structure designed to safely dispose of excess runoff by allowing water to drop vertically from a higher level to a lower level, thereby reducing its erosive velocity. So, the objectives of the drop spillway is to control the slope and the velocity of runoff water to prevent the gully bed erosion, to safely convey excess runoff, to stabilize the gully and its bank, to prevent the further deepening of the gully. Here is the diagram of the drop spillway. I hope you all clearly see this picture of the drop spillway. It may be useful for you for the further studies. So here the water is flowing from a higher level to a lower level. So that is the definition explained in a drop spillway. A drop spillway is a permanent gully control structure designed to safely dispose of excess runoff by allowing water to drop vertically from a higher level to a lower level, thereby reducing its erosive velocity. So now let's move on to the purpose of the drop spillway, and in that there are main components. First is inlet, which collects and directs the runoff into the structure, and the drop section allows water to descend from the higher level. Energy dissipation basin reduces the energy and velocity of flowing water, and at last outlet safely releases water downstreams. Foundations and side walls provides stability and prevent the undermining. So now let's and the advantages of the drop spillway are: provides effective long-term gully control suitable for areas with considerable elevation differences, protect the gully bed from the erosion, safely dispose of runoff, reduces the risk of the gully expansion. The purpose of the drop spillway is nothing but a drop spillway is a structure used to safely carry the water from a higher elevation to a lower elevation while protecting the soil and channel from the erosion. So the main purpose of the drop spillway is to control the water flow and safely convey the excess runoff, to reduce the water velocity before it reaches the downstream channel, to prevent the gully erosion and further deepening of the gully, to control the elevation of the gully bed, to dissipate the excess energy of the flowing water, to protect the downstream area from scouring and erosion. It is to stabilize the steep channels and the waterways. It is to safely dispose of surplus water from the agricultural and the watershed areas. It is to control the headward erosion in gullies. It is to reduce the water velocity and the energy. It is to stabilize the gully bed. It is to prevent further deepening and the widening of the gullies. It is to control the water flow and safely convey the excess runoff, to reduce the water velocity before it reaches the downstream channel, to prevent the gully erosion and further deepening of the gully, to control the elevation of the gully bed, to dissipate the excess energy of the flowing water, to protect the downstream area from scouring and the erosion, to stabilize the steep channels and the waterways, to safely dispose of surplus water from agricultural and watershed areas. So these are the purpose of the drop spillway. So the next is a chute spillway. So chute spillway is nothing but it is a permanent gully control structure used to safely convey runoff from a higher elevation to a lower elevation through a sloping channel, thereby reducing erosion and preventing gully advancement. A chute spillway is a permanent gully control structure that carries water safely from a steep slope or from a higher elevation to a lower elevation through specially constructed lined channel. So I hope you all are able to see the picture of the chute spillway where a higher elevation, where a permanent gully control structure that carries safely down a steep slope from a higher elevation to a lower elevation through a specially constructed lined channel.
So the chute spillway is a permanent gully control structure used to safely convey runoff water from a higher elevation to a lower elevation through a sloping channel, thereby reducing erosion and preventing gully advancement. So the picture is now from the top of the spillway the water flow downwards. So it is from a higher elevation to a lower elevation, and it is specially constructed with a lined channel. So the main components, as we all see in a drop spillway, the main components now in chute spillway, the main components are inlet, chute, energy dissipator, outlet, and the side walls. So inlet gets the water into the chute, and the chute is where next to the water enters into the chute section. In the chute section, a sloping protected channel that carries water downwards, and next to the energy dissipator, it reduces the energy and the velocity of the water, and at last the outlet areas discharges water safely into the downstream channel. The side walls prevent water from flowing outside the chute. So if there is unnecessary leakages present in the chute, unnecessary walls in the chute, side walls prevent water from the flowing outside the chute. So the advantages is suitable for steep slopes, provides safe passage for higher runoff, gives good protection against erosion, requires relatively low maintenance when suitable for the steep slopes, provides safe passage for high runoff, gives good protection gives good protection against erosion, requires relatively low maintenance when properly constructed, provide long-term gully stabilization. So these are the advantages of the chute spillway. And the next is the purpose of the chute spillway. The main purpose of the chute spillway is to safely convey excess runoff water from a higher level to a lower level, to control the water flow on a steep slopes, to prevent soil erosion and gully formation, to reduce the erosive effect of the high velocity water, to protect the gully bed and the side slopes, to safely dispose of surplus water into the downstream channel, to prevent the damage to the agricultural land and nearby structures, to stabilize the steep waterways and the gullies. It is to safely dispose of the excess runoff and to control the headward erosion. It may also reduce the erosive force of the flowing water, and it may become to stabilize the gully beds and the side slope. Once again, I repeat the purpose of the chute spillway. It is to safely convey excess runoff water from a higher level to a lower level. It is to control the water flow on a steep slopes. It is to prevent the soil erosion and the gully formation. It is to reduce the erosive effect of high velocity water. It is to protect the gully bed and the side slopes, to safely dispose of surplus water into the downstream channel. It is to prevent the damage of agricultural land and nearby structures, to stabilize steep waterways and the gullies. So the last is drop inlet spillway. So a drop inlet spillway is nothing. It's a permanent water control structure in which runoff water enters through an inlet opening at or near the ground surface and then flows through a vertical or inclined conduct to a lower elevation. So a drop inlet spillway is a permanent gully control structure designed to safely dispose the excess runoff by allowing water to enter vertically through an inlet drop to a lower level, thereby reducing a flow velocity and preventing the gully erosion. So this is a drop inlet spillway diagram. It's a systematic diagram, so I hope you all can able to study as easier when compared to other two spillways. It is an important diagram, so please go through the diagram. So drop inlet spillway, I once again explain it, a permanent water control structure in which runoff enters through an inlet opening at or near the ground surface and runs and then flows through a vertical or inclined conduit to a lower elevation. So the main component is inlet structure, vertical or inclined shaft, conduit or pipe. Outlet structure, energy dissipator. So the inlet structure, it may collects and admits runoff water. Vertical or inclined shaft carries water downward. Conduit or pipe conveys water safely to the outlet. Outlet structure releases water safely to the downstream. Energy dissipator reduces the velocity and energy of the flowing water. Energy of the flowing water. These are the main components. So there are 5 main components. What are they? Is inlet structure, vertical or inclined shaft, conduit or pipe, outlet structure, energy dissipator. So in inlet structure, it may collects and admits the runoff water. Vertical or inlet shaft carries water downward. Conduit or pipe conveys water safely to the outlet. So in outlet structure, conveys water safely to the outlet. An outlet structure releases water is safely to the downstreams. Energy dissipator reduces the velocity and the energy of the flowing water. So the purpose of the drop inlet spillway is it may safely carry excess runoff water from a higher elevation to a lower elevation. It is to control the flow of water in waterways and the gullies, to prevent the soil erosion and the gully formation, to reduce the velocity and the energy of the flowing water. It is to protect the agricultural land and nearby structures from the runoff damage. It is to protect the agricultural land and the safely carry excess runoff water from a higher elevation to a lower elevation. It is to control the flow of water in waterways and gullies, which may prevent the soil erosion and the gully formation. It is to reduce the velocity and the energy of flowing water, to protect the agricultural land and nearby structures from runoff damage, to prevent the further deepening of the gullies, to safely discharge water into the downstream channel, to provide the long-term control of the runoff and erosion. So it is to control the headward erosion. It safely pass excess runoff, to reduce the erosion flow of water, to stabilize the gully bed and the erosion. So once again, in the sense, gully control structures are engineering and biological measures constructed to reduce the runoff velocity, check soil erosion and stabilize the gullies. These structures help in preventing the
further widening and the deepening of the gullies. The gully control structures are engineering structures constructed across or along the gullies to reduce the speed of flowing water, control soil erosion, and stabilize the gullies. They also help to retain the sediment and improve the infiltration. I hope you all understand about the gully control structures. So that's all for today. So thank you all. I hope you all understand about the spillways and its types and its purposes. Thank you all.